to be walking you through my journey into the world of machine learning and how I broke into this field. So let's start. So starting with my journey, I finished my undergraduate studies in electrical engineering in 2013, and post that I started working for a pharmaceutical company called ZS Associates, where I was working as a business analyst. And that's when I realized analytics wasn't my calling, and I wanted to work in a more technical role, which involved more coding and machine learning. So I decided to make a move to data science, and I joined WNS Global Services in 2016. But 2 years into the role, I felt that I needed more formal education into the field, and that's when I started applying for my master's in the US, and I got admission in UW, and I pursued my MSDS from UW post that. And while studying master's in data science at University of Washington, I was also interning for a startup called Blue Canoe Learning as a machine learning intern, and that's when I got like the exposure to try out like actual machine learning for the first time, and that's when I got into like building end-to-end machine learning models and deploying them for the users to like try them out. And post my internship and graduation, I started working for Microsoft as a machine learning engineer. And I'm currently working in their Azure machine learning platform, where we are developing a platform to enable data scientists train their models on. So that's about my journey. So let's look into how I broke it into the world of machine learning. So to understand the difference between data science and machine learning, I find this Venn diagram pretty helpful. It was originally given by Drew Convoy, um, and this is the Venn diagram that popularized data science to many people. So the most intriguing part of this Venn diagram is the intersection between the hacking skills and substantive expertise. So these are the people who are perfectly capable of extracting and structuring their data, and likely they know a lot about the field already, and they know enough Python to run a linear regression model. So these people are the people who can actually report the coefficients of a linear regression model, but they lack any understanding of what those coefficients mean. So I wouldn't recommend anyone to target this region especially, but there are the intersection between hacking skills and a good amount of stats knowledge is where machine learning lies, and a good amount of skills in hacking, stats, and domain expertise is where data science lies, and the intersection between domain knowledge and stats is where the traditional research lies. So depending upon what interests you and what skills you're looking to develop, you can target different roles that are like currently in the market, like data science, ML engineer, data engineer, software development. So let's talk more formally about what a data scientist versus a machine learning engineer does in the industry. So as a data scientist, you are more responsible for stakeholder facing deliverable that helps the company make data driven decisions. So basically a data scientist is like more involved with drawing meaningful insights from large data sets and sharing this context with the business leaders. So for a data scientist, your skills range from technical to soft skills and domain knowledge. Whereas a ML engineer is like more responsible for data science job plus software engineering job. So an ML engineer would work on developing services that run in production. So for example, if you're working as a machine learning engineer at Netflix, so you would be required to develop a recommendation engine that can be run in a live environment, which like basically when you go to Netflix, you get some recommendations, right? So your model would be responsible for generating those recommendations, which are fast and also can scale up to that level of the Netflix users. So ML engineers like continuously train their models with the new data that is incoming, and also maintain the model which is already in place, and they track the performance of the model on a continuous basis. So that's like the basic difference between a data scientist and a machine learning engineer. Moving on to like what are the skills required to break into either of the roles. Let's look at different skills individually. So the first and foremost skill that is most important here is linear algebra. So I'm sure like most of you have taken some courses on linear algebra in high school or at undergrad level, but I would suggest you focus a lot on that subject because that's like the first starting point for any machine learning algorithm or deep learning algorithm. So these are some sources that I personally found helpful for my interview preparation. Like Khan Academy is pretty good for linear algebra, and again there's a YouTube channel called 3 Blue 1 Brown, which is pretty good for linear algebra. The next most important subject for ML is like stats and probability. Again, you might have a lot of courses being offered at your university, so please do enroll into one of them. Otherwise, there is a very good course by Joseph Blitzstein. He teaches a Stat 110 in Harvard, and he has like all the course on YouTube. So feel free to go through that. Once you have linear algebra and stats in your pocket, the next thing to target is a programming language. So these days, most of the programming languages support machine learning. You can pick any of the language, but the most common ones that are used are Python and R. So feel free to select one good language that interests you. Um, and one more thing that is really important for a data scientist or machine learning engineer is data visualization. Because, like I mentioned, a data scientist is required to share his findings, his projects to a large variety of business leaders. And good visualizations like do impress them so faster than any text on a slide. So it's really important to understand how you make a good visualization. So this is one of my favorite books for data visualization. You feel free to go through that in your free time and also try to pick up a tool that helps you visualize data like Tableau or Power BI, whichever you feel more comfortable with. So once you have like the basics of linear algebra, stats, and a programming language in place, that's when you move to the actual machine learning algorithms. So when studying machine learning algorithms, try to go through all the classical algorithms, which help you solve supervised and unsupervised problems. And when going through the algorithms, please do not skip the math, because even like in interviews, I have been asked to derive linear regression and logistic regression. So I wouldn't suggest you skip the math. And just to make things fun, try to implement all the algorithms from scratch. I did that as well during my graduate studies, and here is the link to my implementations. It's on GitHub. Feel free to go through that, and if you, in case you have any doubts, please raise the issue on it. Once you are done with the machine learning algorithm, it's now is the time to move to deep learning algorithms, because deep learning algorithms are more complex, and they assume that you have ML algorithms experience. And while you are doing all the math and the algorithm practice for ML, one thing to keep in mind is you need to keep on practicing your classical software engineering data structures and algorithms as well, because that's the first round of any ML engineer interview or data science interview. So there are some very good websites that help you practice data structures and algorithms like LeetCode, HackerRank, InterviewCake. And by no means I'm endorsing these websites. These are just the websites that help me crack my interviews. So please feel free to look at any of them and find your best place. So once you have all the theoretical skills, it's time to apply all that knowledge to build some cool projects for your resume. So while studying any ML algorithm, start thinking of a problem that you face every day, right? Like, for example, you might want to see if it's going to rain in Seattle tomorrow. So you have all the weather data on internet. Try to gather data for it. And if you can find enough data, I bet you can like, solve the problem using machine learning. And in case you're not able to think of a problem, it's not a big deal. There is Kaggle. On Kaggle, you have a wide variety of problems relating to different fields like computer vision, NLP, machine translation. Just pick up any problem and try to apply all the algorithms that you studied in the past, and try to figure out which algorithm would work the best. And one more thing that I would like to suggest here is, when you are initially starting in the field of data science or machine learning, like try to have as diverse projects on your profile as possible, because when you're starting, you don't really know what would be interesting to you. For example, if you've never tried natural language processing, you would never know what actually lies in NLP. So I would suggest that you have a project in each of the fields like vision, NLP, machine translation, and then you can decide which field actually interests you and you can further develop on that. Um, so while working on a machine learning project, there's one more very important thing to keep in mind is like try to include all components of an ML application in your project. Because like most of us try to focus on data preparation, training the model, and then we are done. But I would suggest we look into each of the components that are involved in our ML application. So please focus on deploying your model as well, and so that a user can use it like I come to your application, I can see the predictions that your model is spitting out. So experiment with one of the cloud systems. Most of the cloud systems these days, Azure or AWS, have free credits for student. So use it for data manipulation, training, and deployment of your models. Try to create a simple UI which takes an input and gets predictions from the deployed model. Your UI can be as simple as a website, GUI, a REST API, or a command line interface tool. So you should just be able to see how you integrate the machine learning model end to end. And once you have all the components in place, try to organize your project and show it off to the world on GitHub. So here is one of the projects that I worked on during my graduate studies. It's basically a voice authentication system, and it does follow, like it has all the components of an ML application. So you can go through it to just see how an ML application is organized. And also a tip here is cloud systems can be very expensive and you can run out of the $100 pretty soon. So try to prepare your code on a subset of the data and test it locally before you run the script on like your complete data set on the cloud. Especially if you're using GPUs to train your models, you're just going to run out of $100 in a day. So try doing it on a small data set on your local machine. Here is one more interesting thing, interesting read by Google, which is called Hidden Technical Debt in Machine Learning. So basically, this paper talks about that ML model training is just like a very small part of the whole infrastructure. It's very important to understand how your models would be deployed in the larger scheme of things. So I would suggest again that please follow all the please try to implement all the components of an ML application to complete a project. Now, once you have all the projects in place, it's really important to like keep yourself updated in the field of data science and ML because it's growing really fast. We have like a paper getting published every 5 minutes or so. I think that's the number, yes. So please keep yourself updated with what's happening in the community. Try to follow different tech companies on Medium. At Microsoft, we have data science at Microsoft page on Medium. As well as Amazon has its own Amazon Science website, which is basically Amazon updates all their researches and the current projects they're working on that website. So try and keep yourself updated through that. Also, please try and read different research papers which are getting published. Like maybe you're interested in NLP or vision. Try to keep up with all the papers getting published in that field. There are different sources of new papers, like you can follow people you like on Twitter, or you can follow different conferences like NIPS or ICML. Otherwise, Archive has all the papers that are published in different conferences. So either of the channels that you can follow. I also have some tips on reading research papers because I understand reading research papers can be really boring and most of us are intimidated by the math in the papers. So this is what I have these are the tips that I've come up with through my experience. So I'm sure most of you must be aware of Andrew Ng. He's one of the most popular professors for ML. So he suggests that we start with reading just the title, abstract, and figures in the first pass. And next, we look into the introduction, conclusion, and figures. And then we read the paper, but we skip the math. And once we are comfortable with that, we read the whole paper again, but we skip the parts that don't make sense. Also, it's important to keep in mind some questions while you're going through the paper. Like, for example, you should think about what is the author trying to accomplish through the paper, what were the key elements of the approach that he or she followed, and what are you reading the paper for? What are you trying to get out of the paper? That's an important question. And once you've read through the paper, what kind of different papers would you like to go through after reading the paper? Because every paper has a references section. So you can go through that as well and try to understand which other papers would help you understand this paper better. And in case that paper interests you and you want to implement that paper from scratch, that's when you try to understand the math, read through the paper again, take some notes on it, derive whatever algorithm is in the paper from scratch. And when you're trying to code out the paper, before you try to code out the paper, I'm sure there are many other people who've tried that, and there are open source codes of the paper. So try to find GitHub repositories that have implemented the paper and go through the codes, but just do not like blindly copy them and run them. Try to rewrite the code from scratch. That will help you understand uh, the, the algorithm much better. And once you have your projects, your theoretical knowledge, and you're updated with the community, that's when you start interviewing. So when you're interviewing, start with networking. Connect with people you're interested in, connect with people working in the companies that you're interested in applying for on LinkedIn, but do not just send bulk requests to all the people working in Amazon. Try to find people working in specific teams that you're interested in, and try to customize a message saying what you are interested, why you want to connect with them, and what are you looking forward, like what are you looking to get from them. So that helps like a person who's seeing the request understand why you are sending them a request instead of just sending a blank request. And also there are like a lot of pre-conferences, conferences happening in machine learning and data science world. Like for example, when I was in graduate school, I attended a lot of Google conferences, which are completely free. So uh, plan to attend them whenever you can find time. And if you're studying in a university or a graduate school, attend the career fairs, talk to the people who are representing the companies, try to understand what they're working on, and if you're interested in that. And when you're working on a resume, try to show all the projects that you worked on and how you implemented each component of that machine learning application. Don't forget to mention the impact you created in the project. For example, if you were retraining BERT, BERT is nothing but a word model. So if you're retraining BERT, just try to mention that what data set you used to train BERT and by how much number did you improve the accuracy. For example, you improved the accuracy by 2% on training it on Wikipedia data. So mention that. Like that delta change you've done is important in the resume. And don't try and write long resumes. Like I've seen people who are very high in the ladder also have one-page resumes. So I think we all can try to keep it as simple and small as possible. There are some very good websites to prepare your resumes. My favorite is Gradle.io, but again, I'm not endorsing any website. Feel free to explore and find your best website. And once you have done your networking, you have your resume, it's time to give some mock interviews, which are very, very important. So it's not just giving mock interviews, it's also important to take mock interviews, find friends, collaborate with them, take their interview and give your interview so that you have like a two-way communication skill that is getting worked on. Also, there are some good websites on internet that help you give mock interviews like RAM. That's what I used in my graduate school. So yeah, give your mock interviews. And once you have an interview lined up, please study about the company and the product, because frankly, most companies are looking to understand how you can solve their problems. So instead of like just trying to brush up on your previous projects, your educational background. Try to understand how you can apply the knowledge that you already have uh, for on the company or the product that you're interviewing for. These days, a lot of companies are also giving take-home challenges that require you to solve a real problem that they have been facing. For example, I had interviewed for Airbnb during my time, and I was required to optimize their recommendations, which a user sees when he or she is looking to travel to some place. So try to understand how you can use your skills to um, help them. So that's all I had about how I broke into the world of machine learning. But feel free to ask me any questions that you have, any challenges that you have been facing. So I see a question here. Is there a link for the Google Slides? I can share the slides with Jacob, and he can probably share that with you guys. I'm not sure how it works with Code. So, Jacob, can I share the slides with you, and can you share them with the students here?
Yes, I can do that.
Okay, thank you. The next question that I have here is, what's your opinion on CUDA and OpenCL or general purpose GPU programming in general? Should it be a regular consideration as an alternative to machine learning for problems that don't lend themselves to machine learning as well? So I think GPU programming is quite helpful to some extent. Like if you're looking to solve machine learning problems, GPU programming is a very small part of it. Like, but it's not a replacement to machine learning at all. Like it's a complete different field altogether. So you have to decide which field that you're which field you're more interested in. The third question is, can you share the link for the slideshow in the chat? I am not sure. I'll share it with Jacob, and he'll probably share it with you guys. Uh, okay, so the next question again is, what are some programs that helps you get scholarship through machine learning? So there are a lot of programs that give you scholarship for machine learning, but they're mostly PhD program. Like Google Brain has a scholarship for machine learning. NVIDIA has a scholarship for machine learning, but they are mostly for PhD students. Like I'm not aware of any programs that are awarded to graduate students myself. Do we have any more questions? Um, I think that's all the questions we have. Then I can share the slides. Okay, we have one more question. Um, so the next question is, what are some languages? I'm not okay used in machine learning. So like I mentioned, these days most of the languages support machine learning frameworks, but the most common one is Python. But there you can use Java, Go, C Sharp. All the languages have machine learning frameworks in them, so you can pick up any language that interests you. The next question is, what would you recommend for students in high school to start doing from now? So my suggestion to high school students would be to focus on linear algebra, statistics and probability, and programming. These are the most important things that will help you break into machine learning world. The next question is, how did I get into this position? So I assume the position being talked about is my role at Microsoft. So to talk about that, like I mentioned, I was pursuing my master's in data science at University of Washington, and post my graduation, I applied for Microsoft data science graduate openings, and that's how I got a call for the interview. I had a screening round, and when I got through the screening round, I had four on-site interviews, which were mostly around the projects that I worked on, machine learning algorithms and deep learning algorithms. And once I got through all those rounds, I got into Microsoft. The next question is, so you wouldn't ever be asked to try and solve a problem and have to determine whether it's better to brute force or train for it like something like train something for it with ML. Yes, you can be asked to do that. In a lot of interviews, they might just ask you, if you do not have an ML algorithm in place, how would you solve it versus solving something with machine learning. So yes, you can be asked such questions. The next question is, what are some good resources for learning about machine learning? So there are a lot of resources on the internet right now to learn machine learning. The best start could be Andrew Enge's course on Coursera on machine learning. It is very basic, but it's a very good course to start with. The next question is calculus important too for machine learning? Yes, very important. So the most important algorithm in machine learning is gradient descent, which uses a lot of calculus. So calculus is very important for machine learning. The next question is, what are some things they ask in an interview? So the interview is very much tailored to the profile that you have currently. So there can be questions about the projects that you worked on. And when I say questions around the project that you worked on, they ask you a lot in detail on the implementation challenges that you faced while working on the projects. And then there are a lot of open-ended questions like case studies and machine learning interviews. Like they would just like ask you, I want to improve my recommendation system. How would you go about designing that? So those are some kind of questions being asked in the interview. And the third type of questions are like coding questions. So they would just like ask you a simple data structure and algorithm questions, which uses a DFS or BFS. So these are some kind of questions asked in the interview. The next question is there a specific style of coding when developing an ML algorithm? Um, the coding style remains the same as any software development product. There is no specific coding style for ML algorithms. It's the same. But the coding for ML algorithms do require some math libraries like NumPy in Python. So yeah, you have to be familiar with those kind of libraries. The next question is, does machine learning involve web development? So machine learning does not directly involve web development, but when you're trying to serve your machine learning model as a service, that's where web development can help you. Like you can have a website which would take an input from the user and show some results to the user. But the model itself does not require any web development. The next question is, can I pursue ML after AS in computer science? I'm not sure what AS stands for. I think that's all the questions we had. Okay, it's Associate of Science. Yes, you can do that. So most of the roles that are currently open for data science or machine learning in the industry require you to have masters. So I would suggest you have a undergraduate degree in computer science and then you can always have a master's in data science or machine learning. So somebody has asked me what topic should we have an undergraduate degree in. Um, that's a very specific question, but it depends upon your interest. But computer science is a degree that would complement a degree, a master's in data science or machine learning. But again, you can enroll into any undergraduate degree and always take subjects on data science and machine learning. So you don't, there is no compulsion on computer science. You can take up any degree in undergraduate studies. Jacob, I think that's all the questions we. Okay, there's one more question. Do we need to master anything before an undergraduate degree? Uh, so there is no definition of mastering anything before an undergraduate degree, but I would suggest uh, please practice your programming skills, like try to be good with data structures, algorithms, and like develop one programming language that is like your primary language. That's the first language you speak. So try to be good in programming. That's like a prerequisite to any role, whether it be data science, data scientist, machine learning engineer, or software engineering. So just pick up any programming language and master that. So Lakshmi has another question, computer programming. Yeah. So yeah, that's what I mean. Pick up any language for computer programming and try to master that. So there's a question, is there any topic in algebra 2 that is also important? So I'm not very sure about what is being taught in algebra 2, but um, linear algebra in general is very important for machine learning. So Lakshmi has a question, is geometry also important for machine learning? So not directly, but if you're trying to solve a machine learning problem that uses geometry, so you might have an upper edge if you're good with geometry. But the algorithms do not directly use geometry, but it's always good to have. The next question is there any specific topic in linear algebra that is used a lot in machine learning? Yes, matrix multiplication, that's very important for machine learning. Like dot product, cross product is something that you need to know for sure. Um, Jacob, I think that's all the questions we had. That's about it.
Other questions?
Yeah, I think I've closed all the questions. Thank you. Bye bye.